Hi everyone, welcome to the fourth grade math channel of Sun Devil Learning Labs. My name is Miss Houston and today we're going to be talking about metric length. So for our first, before we go into our lesson today, we're going to talk about the objective and our materials. For our objective, go ahead and say this with me. I can apply conversions to metric length and relate it to real-world examples. Perfect. So the only materials that you're going to need today are a piece of paper, pencil, and eraser. That way you can solve the problems with me as we do them digitally together. So before we go into anything, let's talk. What is the metric system and what's the US system? So when we're talking about length, we're talking about how long something is. For example, I have this marker here. We're talking about how long the marker is. So this marker is probably about, I don't know, maybe 4 inches long. Now, you just heard what I said, right? I said 4 inches. That is a type of system. If you guys can see on our video here, we have the word inches, and it's under the word customary. So there are different ways of explaining how things are measured. You can measure them in inches, feet, yards, miles, and even more. Those tend to be used in the United States. The United States has a different system for measuring than the rest of the world does. What the rest of the world uses is the metric system, and that is this system right here. They use kilometers, meters, centimeters, and even more. Those are how they measure things. So instead of saying that this pen is 4 inches, they might say that it's about maybe 10 centimeters long. Now, you guys might be like, oh, what's a centimeter versus an inch and everything? We're going to go into discussion about that today. I just want you to know that there is a difference between metric and customary units. Metric is what most of the world uses. So even though the US uses something different, we're still going to talk about the metric system because it's important to know what everyone else around the world uses. It's also going to be seen a whole lot in your lives, and it's going to apply to real world scenarios. So our vocabulary for today is convert. The word convert means to express a measurement in different units and rename the units. So for example, I'm going to say it in customary and then metric. So if you wanted to say, oh, 12 inches, I have a piece of paper that's about 12 inches long, you could say, instead of 12 inches, it's a foot long. 12 inches and 1 foot are the same thing. It's just converting it, kind of like saying 10 ones on our place value mat is the same as one set of 10. And then in the metric, 10 millimeters is the same as 1 centimeter. And we're going to practice that today. So let's move on to our first slide. Examples. So we're going to go back to the metric. We're going to talk about centimeters, meters, and kilometers today. Let's see. So let's start with centimeters. If you're thinking of centimeters, 1 centimeter, and we're talking about 1 centimeter, it's about the width of a highlighter. So if I have my highlighter right here, it's going to be a little bit wider than this. I'm going to hold it up to the camera. So a centimeter is actually pretty small, right? It's definitely smaller than an inch, just to kind of help you guys understand that, like something that you can relate it to. It's also the length of a staple, and it's half of the width of a penny. Pennies are small, right? Now, if you think about half of a penny, that's really small. Centimeters are very minuscule, and there's not a lot to them. So they're very small units that are used to measure length. Now let's talk about a meter. How much is a meter? Well, a meter is about the length of a guitar. And a guitar is kind of big, right? A guitar is about 3 feet tall, like a yardstick. So if you see down here, we also have length of a yardstick. That's another way of thinking about 1 meter. Or the length of a baseball stick. If you guys love playing baseball and you hold up your baseball stick, that is about the length of 1 meter. Let's talk about kilometers now. Kilometer is much bigger. It's about over half of a mile long. So, for example, if you live in Arizona, each of our streetlights are separated about a mile away from each other. So if you thought about the distance from one streetlight to another streetlight, and you did about half of that, that's a kilometer. And to walk 1 kilometer, it takes about 12 minutes. So kilometers are pretty big, right? They're way bigger than a centimeter. This is about a centimeter. A kilometer takes 12 minutes to walk that distance, so it's a whole lot bigger. Now, if you guys want, you can even pause the video now and talk about some other examples with someone around you, whether it's a friend, parent, teacher, guardian, family member, anyone. Just talk about centimeters, meters, and kilometers. Maybe look around you. See what you would say, oh, Maybe this is about 10 centimeters long, and try to measure stuff around you. If you want, go ahead and pause the video and do that. Otherwise, we're going to continue with our lesson. So we're going to talk about measuring these. We have a few different options here. We have like length of a highway, paper clip, piece of paper, height of a wall, pencil, and the height of a dog. How would you guys measure these? Would you measure them in centimeters, meters, or kilometers? Now remember, a centimeter is the smaller unit of length, meters a bit bigger, and a kilometer is a lot bigger, like it takes 12 minutes to walk 1 kilometer. So go ahead, pause the video, and fill in the blanks here. How do you think is the best way, most efficient way to measure each of these? And then when you're done, unpause the video and we'll go over the answers. Wonderful job, guys. So let's go over the answers that you came up with. Length of a highway. So highways are really long, right? Those are roads that we drive across because they're so long. Now, if that's really long, we don't want to measure it with a centimeter, right? This is about the width of a centimeter. So that's way too tiny. If you measured a highway in centimeters, that would be a gigantic number. So let's try meters. 1 meter is about the size of a guitar, right? Well, if you laid out a whole bunch of guitars on the highway, that's still going to be a lot of guitars, right? So meters also too small. So we would measure the length of a highway in kilometers. Remember, a kilometer takes about 12 minutes to walk. So if you did that, a highway would still be a lot of kilometers, but it would be a more efficient and smaller number than the other units. Now let's talk about a paperclip. Paperclip's tiny, right? Like, I don't know, it's maybe the size of like 4 of your fingers put together at the most. Even that's kind of big. So paperclip's tiny. That is definitely smaller than a guitar, but it's about like, it's a little bit bigger than the width of this, right? We could say maybe it's a few centimeters, right? So we would measure a paperclip in centimeters. I think paperclips are about 4 centimeters wide. That's what I read last night. Not wide, I'm sorry, 4 centimeters long. So let's try a piece of paper now. If I have a piece of paper, and here's a piece of paper right here, we could measure this in centimeters, right? If I took my highlighter and went like 1, 2, 3, 4, and so on, you could definitely do this in centimeters. Or you could do this in meters. And it would be, like, this piece of paper is definitely smaller than a guitar. So you could say that it's like 1/3 of a meter because it's less than that. Kilometers would definitely be too big for this though. So we're gonna say centimeters are our best bet because like we said before, 1, 2, 3, 4. This would probably be about maybe like 16, 20 centimeters. So centimeters is going to be our best bet when we are labeling this label. Centimeter. Let's talk about the height of a wall. If you guys look behind me, I have a wall here. See? That's a wall. A wall is kind of big, right? It's bigger than a guitar for sure, but it's not a 12-minute walk to go up my wall if I could climb my wall like Spider-Man. So if we were looking at this, we would measure my wall in meters, right? That would be the most reasonable and efficient way of measuring it. Now, pencil. How we measure this? Centimeters, right? Because it's smaller than a guitar, we can't walk across a pencil. Centimeters are definitely a smaller unit of measurement. Now, the height of a dog. Dogs aren't that tall, right? Maybe 1, 2 feet tall at the absolute most. If you have a tiny little Chihuahua, it might even be like 4 inches off the ground. So we would measure the height of a dog in centimeters because a centimeter is a small unit of measurement. Perfect job, guys. So let's move on to our next topic for today. We're going to talk about equivalent conversions. So we're going to look at only this first table on the left here, the centimeters to meters conversion. We know that 100 centimeters is equivalent to 1 meter. So remember back in our place value chart, 10 ones can be traded up for 1 10. Just like this, if you have 100 centimeters, you can trade it up and say, instead of 100 centimeters, I have 1 meter. So let's fill in the rest of our chart here. If we have 200 centimeters, we're going to have 2 meters, right? Because 100 for 1 centimeter, 100 centimeters for 1 meter, 200 centimeters for 2 meters. So we're going to put 2 meters here. And this M means meters. The CM means centimeters, and the km means kilometers. 300 centimeters. What do you guys think would be here? If 100 centimeters is 1 meter, 200 centimeters is 2 meters, 300 centimeters is going to be 3 meters, right? Now let's do this next one. I bolded this because it's not 400, we're looking at 800 this time. So if we have 800 centimeters, every 100 centimeters is 1 meter. So since we have 8 sets of 100, this means that it's going to convert to 8 meters. Perfect. Now let's do the opposite of this. Let's go from meters to centimeters in our other table. So we said 1 meter is the same as 100 centimeters. So if we have 2 meters, if we have double the amount, 2 meters is going to be 200 centimeters. And what if we had triple 100? It would be 300 centimeters. Now, we have 8 meters. 8 meters means that we have 8 sets of 100 centimeters. So if we have 8 sets of 100, this is going to be 800 centimeters, just like that. Wonderful. So we're going to clear our drawings, and we are going to talk about kilometers and meters now. Kilometers and meters. Remember, kilometers is the really big one. It's about half a mile long. And a meter is the one that's like the size of a baseball bat. So 1 kilometer is the same as 1,000 meters. If you had 1,000 baseball bats stacked up on top of each other, that would be a kilometer. Now, if you had 2 kilometers, you would need 2,000 baseball bats stacked up on each other. 3 kilometers would be 3,000 baseball bats stacked up on top of each other. So we're going to fill this in with 3,000 meters. Oops. Now, what about 8 kilometers? For every 1,000 meters, it's 1 kilometer. So 8 times 1,000 would be 8,000 meters. Perfect. So now that we've gone over equivalent conversions, we are going to apply this to some real-world situations. And we're going to be doing that by filling in the blank first, though. That way we can start practicing it, and then we can apply it to like doing distance problems, word problems together. So right here, I have a bubble map for us. This is called a bond. So what we want to do is, at the top here, we have the number 150 centimeters, right? And what we're saying is we want to find 2 numbers that when added together, it equals 150 centimeters. So we know that one of the numbers is 1 meter. We need to figure out what the other number is. And we want this number to be in centimeters. So let's write out an equation here. We are saying 1 meter plus something centimeters, question centimeters, equals 150 centimeters. So what we have to do is we need all of our units to be the same. See how we have a meter and then a centimeter and then a meter in our equation? We can't have that. You can't add those numbers and just say, oh, well, 1 plus 149 is 150. We can't do that because the labels aren't the same. We need to make them the same first. So what we're going to do is we're going to figure out how many centimeters is in 1 meter. It's 100 centimeters, right? So we're going to say that 1 meter equals 100 centimeters. And then we're going to write a brand new equation now. So we're going to say 100 centimeters plus a certain number of centimeters equals 150 centimeters. All of my units are now the same, right? They all say centimeters. So we can solve this. What number plus 150, what number plus 100 equals 150? That'd be 50, right? So our answer for this highlighted spot here is going to be 50 centimeters. Because 100 centimeters plus 50 centimeters equals 150 centimeters. So if you look at this, we are essentially saying that 1 meter plus 50 centimeters is the same thing as 150 centimeters. So this is practicing something called mixed conversions, mixed sets of conversions, because we have different labels and we need to convert them before we can add them together or subtract. So next up, we have 4 meters. And we need to have 2 meters plus a number of centimeters, which equals 4 meters. So let's write an equation. 2 meters plus question centimeters equals 4 meters. So we want to put all of this into centimeters, right? Because we're solving in centimeters. So 1 meter equals 100 centimeters. This is our conversion factor, remember? This is so important to remember. I'm going to circle this because this is our conversion that we are working with. So let's write a new equation. If 1 meter is 100 centimeters, we have 2 meters. So 2 times 100 would be 200. So we're going to write 200 centimeters plus question centimeters equals, now we need to convert this to centimeters too. What's 4 times 100? 400. So this is going to be 400 centimeters. Now what plus 200 equals 400? 200, right? So we're going to write 200 centimeters equals our question mark. And we're going to put the number 200 centimeters here. So as we have found out from this, 2 meters plus 200 centimeters is the exact same thing as 4 meters. Wonderful. So let's move on to a word problem together then. So here's our first problem. Charlie's grandmother lives far away and he wants to go drive to see her. How nice, right? He drove 400 kilometers yesterday and 300 kilometers plus 20 meters today. How far has he driven so far? So we need to set up an equation, and I've started this for us so far. So he drove 400 kilometers yesterday. So I started our equation with 400 kilometers. And then today he drove 300 kilometers and 20 meters. So we want to figure out what the total of this. Now we can't just add these together 100%, right? We need to do some conversions because we have kilometers, kilometers, meters. Uh-oh, that's not the same thing. So let's do some conversions. Now we know, I'm going to write an equivalent here. We want to do meters to kilometers. We know that 1,000 meters is the same thing as 1 kilometer. And this is our conversion that's important for us to remember. So let's rewrite this equation right here using meters instead of kilometers. So if we have 400 kilometers and we want to say 400 kilometers in meters, we're going to do 400 times 1,000, right? Because 1,000 meters is 1 kilometer. So what's 400 times 1,000? It is going to be the number 400,000. And then I'm going to write something out that way you guys can see the work in a second. So then we're going to do plus 300 kilometers. 300 kilometers times 1,000 is going to be 300,000. And then 20 meters is the same as it was. So we're going to add 20 meters. And then that equals question mark. I'm going to write the meters here. That way you guys can see that they're all the same thing. And that's our new equation. But we're going to backtrack so that you guys could see the multiplication that I just did. So I'm going to get my pencil. And for example, we're going to only do the 400 kilometers to meters. So what I did was I did 400 multiplied by 1,000 equals, and that's how you get 400,000. Just like that. Sorry guys, the pencil's kind of hard to do on here. But 400 times 1,000 is 400,000. That's how I got that number, and then 300 times 1,000 is 300,000. So that's how we got the numbers for those. So I'm going to go ahead and erase that. That we have our space to do the rest of the problem. So we have 400,000 meters plus 300,000 meters plus 20 meters. We can add all these together now, right? Let's use our standard algorithm that we learned last week. So I'm going to put 400,000 meters. And then we're going to write 300,000 underneath it. And then we're going to write 20 underneath that. And we want to add all of these together. So we're going to get a total of 700,020 meters. Now we need to write the meters because this label is so important. We're not doing this in kilometers or in centimeters. If we did it in centimeters, this would be a huge number, right? So I'm going to text this. That way we can all see the number a little bit better. 700,020 meters. Ta-da! That's our answer in meters. Now, what if we wanted this answer to be in kilometers, right? Well, if we wanted it to be in kilometers, we would have to divide it by 1,000 in order to get it down like that. So we're just going to leave it in meters right now. This is a simpler form. We'll practice converting it down in a different lesson later on. But for right now, this is perfect for our answer. So our answer is that Charlie has driven a total of 700,020 meters so far. So let's put this in perspective. If we are looking at this, that means that Charlie has driven, if you put 700,000 guitars down just like that, that's how far he's driven. That's really far, right? Charlie's almost to his grandmother's house. He's got to be close. Okay, so let's move on to our next problem now. This is our last word problem for the day. So here's a new one. Mark decides to drive to the beach. Oh man, beaches are perfect and it's summertime, so fun. It's a total of 100 kilometers away. Okay, if it's 100 kilometers away, if Mark has already driven 70,000 kilometers in 13 meters, how much longer does he have to drive? So this is actually going to be a subtraction problem, right? Instead of addition. I wrote addition here. We're going to cross that out and we're going to put subtraction because the last one was addition, but this one is going to be a subtraction problem. So we're going to draw it like that. Because we want to do 70 kilometers plus 13 meters plus question mark equals 100 kilometers. So let's solve this. What we're going to do for our first problem is I'm going to grab my text box. We're going to convert this all to meters. Now remember, 1,000 meters is equivalent to 1 kilometer, just like that. So let's write this out. If we have 100 kilometers, we want to put this into meters, right? So this is going to be 100,000 meters minus 70 kilometers to meters. That's going to be 70,000 meters plus 13 meters because you need to add those in. So what we're going to do is, it's 70 kilometers and 13 meters. So what we're going to do is we're just going to add these together first. We're going to say 70,000 plus 13, which is going to be 83,000 meters. Oops, can't type. There we go. 80,000 meters equals question mark. Just like that. So if we were going to set up a standard algorithm problem, it's going to look like this. 100,000 minus 83,000. And then we're going to put equals question mark because we're not sure, right? But instead of doing that, we're just going to do a bar across. So we want to solve this problem. 100,000 minus 83,000. So 0 minus 0 is still 0. Now we're solving down. We're doing standard algorithm here. So we're going to put a 0 in the ones place. 0 minus 0 is 0. 0 minus 0 is 0. Uh-oh, we need a comma. So we're going to put a comma here. Now we have 0 minus 3. Can't do that, right? So we need to borrow from the next place over. But wait, this is a 0 too. Can't do that either. So we're going to borrow from the next place. This 1 becomes a 0, and this 0 becomes a 10. We still need to borrow from here, though, because we needed it for 0 minus 3. So the 10 becomes a 9, and this 0 becomes a 10. Now we can finish the problem. 10 minus 3, 7. And 9 minus 8 is going to be 1. And then 0 minus nothing is nothing, so we're not going to write anything. So our answer is 17,000. Mark still has to drive 17,000 miles. I'm sorry, 17,000 meters in order to get to the beach. Just like that. Now, if we wanted to convert this to kilometers, we would divide it by 1,000, right? Because there's 1,000 meters in 1 kilometer. So we could also say that he has to drive 17 kilometers in order to get to the beach. In the beach. Now, these are the exact same thing, right? 17,000 meters is the same as 17 kilometers. So you could say either answer and they will both be correct. And this is the conversion I was talking about in the previous problem that we didn't do. We just left it in meters. Instead, this problem, we converted it to kilometers also. And you can write the answer in either way. So that is how much longer that Mark has to go in order to get to the beach. So here's an overview for today. Our objective was I can apply conversions to metric length and relate it to real-world examples. We talked about Charlie driving to his grandmother's house and Mark driving to the beach. We also talked about how much a meter, centimeter, and kilometer actually are. Remember, a centimeter is about the width of a highlighter. A meter is about the height of a guitar or a baseball stick or even a yardstick. And a kilometer is about half of a mile. So it takes 12 minutes to walk 1 kilometer. Anyways, that was a super great lesson today. I hope that you guys all have a wonderful day and that you had fun learning this with me today.